we have multiplication of algebraic fractions. We have to use the same rule like for multiplication of fractions. So we have to multiply numerator times numerator, denominator times denominator. So we will put one fraction bar, and in the numerator we will have b minus a. We will put in parentheses because we have subtractions between these two variables. And we have times a squared b minus 16b cubed. In the denominator we have a squared plus 3ab minus 4b squared times ab squared minus 4b cubed. Now we have to reduce to the lowest terms. We know that we can reduce when we have multiplication. We reduce numerator with denominator, and we have to have in the parentheses exactly the same expressions. At that moment we don't have, so we have to do factorization. So first expression I will rewrite. This is b minus a, and from this parenthesis we can factorize b. So in parentheses will be a squared minus 16b squared, and in the denominator we will have in first parenthesis, if we forget about b, we will have trinomial, quadratic trinomial, so we can try to use grouping method to factorize this trinomial. Let me copy this expression. We have a squared plus 3ab minus 4b squared. So let's forget about the b, so it will be a squared plus 3a minus 4. Coefficient before a is 1, so now we have to find two numbers which I multiply and I will have negative 4, and when I add these two numbers I will have coefficient before a, so 3. This is 4 and negative 1. So now we can rewrite our expression that it will be a squared, we have to copy, and 3ab we can rewrite that this is 4ab minus 1ab, and negative 4b squared we will copy. So now we can factorize from these two first terms a, and we will have in parentheses a plus 4b, and from the last two last terms we will factorize negative 1b, so it will be in parentheses a plus 4b. So a plus 4b we have in parentheses, so we can factorize a plus 4b, and in the second parenthesis we will have exactly what we have before first parenthesis and before the second parenthesis, so it will be a minus 1b, so this is b. So now we can rewrite our denominator that this is a plus 4b times a minus b, and from the last parenthesis we can factorize b squared. So in parentheses we will have a minus 4b, so this is equal because we have in the denominator a minus b, so I will factorize negative 1 from the first parenthesis, and we'll have negative 1 before parenthesis will be negative b plus a. When I multiply expression in parentheses by negative 1, I will have exactly the same what we have here, b minus a, and we have b, and in the second parenthesis we can rewrite that this is a squared minus 4b to second power. 16b squared, this is 4b to second power. So now we have the difference of two perfect squares. We can use this formula and we will copy our denominator. We have a plus 4b times a minus b times b squared times a minus 4b. This is equal. In the first parenthesis, first I will put positive variable, so negative. I don't have to put this negative one. I will put only negative sign, and in parenthesis we will have a minus b times b. I will put b before this parenthesis, and next, like I said, difference of two perfect squares. So this is a minus 4b times a plus 4b. Let me remind you this formula. When we have x squared minus y squared, this is equal x minus y times x plus y. In our example, x is equal a, and b and y, of course, is equal 4b. So I just use this formula. So this is over. First I will put b squared, and next I will put the parentheses. So we have a plus 4b times a minus b times a minus 4b. Next, when we have the same expression in parentheses, we can reduce. So a minus b and a minus b, a minus 4 with a minus 4, and a plus 4b with a plus 4b. And we have now only that this is equal negative b over b squared. B squared, we can rewrite that this is b times b. So now we can reduce b with b. This is 1 and 1. So we have that this is negative 1 over b. This is my solution.